Josh Waitzkin became a chess world champion, then a Tai Chi world champion.
Same brain. How does that even happen? You know that feeling, right? Every time you start something new, it feels like you're a complete beginner all over again. But then you see these people who just seem to carry their skills from one thing to the next, learning faster every single time. Well, that's not luck. It's a very specific skill. It's about knowing how to transfer what you already know to learn anything new way faster.
The truth is, most of the skills you learn get trapped. You know, that coding framework you spent a year mastering? Yeah, it's going to be obsolete in 18 months. Those killer sales techniques from your last job, they might just fall flat in a new company. You put in thousands of hours building up this expertise, and then life changes, and it feels like you're right back at square one. We're always told that learning compounds, but for most of us, it really doesn't. Each skill just dies in its own little box.
But what if the solution isn't just to learn more stuff? What if it's to learn things differently? What Waitzkin figured out is something cognitive scientists call transfer learning. See, it's not about what you learn, it's about how you learn it, how you encode it in your brain. And that one little difference is what separates skills that expire from skills that multiply.
Okay, so let's get right into the mechanics of this. Section 1, we're talking surface details versus deep structure. This is the absolute core reason why some of your knowledge is portable, and most of it is just stuck in place.
So your brain is actually doing something called near transfer all the time. You learn to drive a Honda, you can pretty much jump into a Toyota and be fine. It's easy, it's automatic. But the real magic, the thing that changes the game, is far transfer. This is where chess strategy suddenly applies to a business negotiation, or a musician's knack for pattern recognition makes them an amazing coder. Far transfer is rare, it's difficult, and it is incredibly powerful.
So that's the million-dollar question, isn't it? What's the secret? How do you actually unlock this powerful far transfer that lets you connect these seemingly unrelated worlds?
Okay, here's the key difference. The knight's L-shaped move in chess, that's a surface feature. That piece of knowledge is completely trapped inside the game of chess. It has nowhere else to go. But the principle of controlling the center to give yourself more options, well, that's a relational structure. That same idea transfers to how you position players on a basketball court, how you map out a business strategy, even military tactics. Surface features get stuck. Relational structure travels everywhere.
But here's what most people miss. This isn't some kind of superpower you have to go out and get. Your brain is already wired to find these deep connections. You just have to learn how to feed it the right kind of information. So let's move to section 2 and see how this works. We're going to look at how your brain actually finds these analogies by unpacking this really powerful idea from a cognitive scientist named Dietrich Gentner. It's called structure mapping theory.
Gentner's research shows that your brain tries to match new problems to old ones on 3 different levels. Now, level 1 is the trap, that's surface similarity, where things look alike but they don't actually work the same way. Level 2, literal similarity, that's easy. That's the Honda and the Toyota. But the goal, the key to all of this, is level 3, analogical similarity. This is where things don't look alike at all, but they operate on the exact same underlying principle.
And this leads to this really fascinating paradox. The more abstractly you learn something, by focusing on the core principle instead of the specific example, the more concretely and widely you can apply it. Think about it. Waitzkin didn't transfer chess moves to Tai Chi. He transferred principles of timing, of leverage, of psychological pressure. That's the whole game.
Okay, so that's the theory. Let's get practical. Section 3, 3 techniques for real transfer. This is how you stop just hoping for transfer to happen and start actually engineering it, systematically. Here's a system you can use over and over. First, structure extraction. After you learn something, you have to ask yourself, what is the deep pattern here that would apply in a completely different domain? Second, cross-domain journaling. Actively try to connect what you learned today to a totally different field. This literally trains your brain to look for those deeper similarities. And third, concreteness fading. You start with a very concrete example, you pull out the abstract principle, and then you immediately apply it to a new concrete example.
And as you start doing this, you got to watch out for these common traps. First, don't fall for that surface similarity trap. Second, don't just learn the how-to steps, you have to understand the why behind them. That why is the principle that transfers. And finally, be aware of what's called negative transfer. That's when your old knowledge actually gets in the way, kind of like how a tennis swing can totally mess up your golf swing.
And you know what? This connects back to everything we've covered in this series. Transfer learning isn't just some standalone concept. It's the final piece, the capstone that pulls all the other high-performance learning techniques together into a single system.
So for our final section, let's build what we can call a unified theory of learning and see exactly how transfer learning is the final piece of the puzzle that makes this whole system click.
So just to recap, transfer learning is your ability to take what you know from one context and apply it to a completely different one. It's what lets you succeed when the deep structure matches, even if the surface looks nothing alike.
Remember when we talked about compression? The whole goal of compression is to find the smallest, most elegant description of a pattern. Well, guess what? That small, elegant description is exactly what makes the knowledge portable enough to transfer over to new domains.
And what about chunking? That's the process of building those deep hierarchical patterns that experts use. Well, the highest levels of those chunks, those most abstract principles right at the top, are the very structures that you transfer. So chunking builds the asset and transfer deploys it.
And finally, mental models. What are they, really? They are pre-packaged, pre-abstracted principles that are designed explicitly for transfer. A mental model like feedback loops is a tool you can just carry with you and apply to biology, to economics, to software engineering. They are the ultimate transferable assets.
So look, if you remember just one thing from this entire explainer, please make it this. The golden rule is transfer the structure, not the surface. Always be asking yourself, what is the relational pattern here that survives if I change every single surface detail? That right there, that's the price.
Okay, so here's your one action for tonight. I want you to take one skill you use every day. Could be coding, cooking, parenting, anything. Write down 3 abstract principles that make it work. Then, for each principle, identify one completely different domain where it also applies. That's it. You've just engineered your first deliberate transfer.
And with that, this series is complete. From compression to chunking to mental models and now to transfer, you have a complete system for learning. I'd really recommend revisiting the first explainer to see how it all connects together. And I have one last question for you. What's the one concept from this series that really changed how you think about learning? Let me know down in the comments.